Hello students, today we will discuss very interesting topic in covalent bond, that is polarity of covalent bond. Polarity of covalent bond means we know covalent bond is produced by a sharing of electrons between bonded atoms. Let us see, for example, hydrogen molecule. This is a hydrogen molecule which is produced by sharing of electrons, and the shared pair of electrons between two hydrogen atoms remain in between two atoms. But if you see the electronegativity, we know electronegativity is the tendency of an atom. Every atom has electronegativity value. The electronegativity value of these two hydrogen atoms are same. If electronegativity of these two atoms are same, both are pulling the bonded pair of electron towards itself with the same force. Both are attracting this electron towards itself because they demand electrons. To satisfy the noble gas confliction, they demand electrons. So these two electrons will be attracted by hydrogen, and these two electrons also attracted by the hydrogen. Both are attracting with the same force towards the bonded electron. So the bonded electron as attracted equally by the both atoms, so they remains at the center of two atoms. It remains at the center of two atoms. It will not move towards any atom because both having same electronegativity value. But if you say, so as it is not shifted towards any hydrogen atom, so it remains at the center of two atoms. But if you consider for the formation of fluorine, HF, fluorine and hydrogen, molecule of HF molecule, so fluorine is contribute one electron and hydrogen also contribute one electron, both contributing one electron. Then the bonded pair of electron here, you see whether it will remain at the center or it will be shifted towards the other atom. Let us discuss. Here what happens, this bonded pair of electron is produced and remain in between two atoms. But as fluorine is more electronegativity, the highest electronegativity character of fluorine is much more than compared to hydrogen. As compared to hydrogen, fluorine has more electronegativity value. Then this bonded pair of electron will be shifted towards fluorine because the electronegativity value of fluorine, then the bonded pair will be attracted towards fluorine. So when you are attracted towards fluorine, what happens? This electron will be remain closer to fluorine atom. It will remain very closer to fluorine because fluorine has more attracting power compared to hydrogen. It will be shifted towards fluorine. So as the electron, one hydrogen electron is shifting towards fluorine, that hydrogen electron is going away from hydrogen and moving towards fluorine, then fluorine become partially negative charge, hydrogen become partially positive charge. As the electron, bonded electron shifting towards fluorine and the hydrogen become partially, as it is moving towards fluorine, fluorine is gaining more electron, that's why partially negative charge is produced on the fluorine and partially automatically reverse. Partially positive charge is produced on hydrogen because hydrogen is low electron attracting power than fluorine. So fluorine will become minus and hydrogen will become plus. This formation of partial positive and negative charge in between HF, that's why HF is a polar molecule. You can say it is a polar molecule. So HF is a polar. Polar molecule means formation of partially positive and partially negative charge on the atoms. Then This, we can say, this covalent bond is a polar bond because H is partially positive charge, F is partially negative charge. So the polarity of covalent bond, or the polarity of covalent bond and the polarity of covalent compound depends upon the depends upon different factors. What are the factors affecting the polarity of covalent compound? The factors affecting polarity, mainly first factor is that the nature of bonded atom. We have already discussed, as two bonded, here the bonded atoms are similar nature, that's why non-polar. That means similar atoms means non-polar. If similar atoms, then you can say non-polar. Then dissimilar atoms, dissimilar atom means it leads to polarity, develop polarity in the bond. So if the way the polarity develops, molecules may be or may not be polar. Another third point is very important, that it depends upon the that dipole moment of resulting molecules. Dipole moment of net dipole moments, we can say net dipole moments of the molecule. Net dipole moments of the molecule also it depends. So first is nature of bonded atoms. If they are similar atoms, then non-polar. If dissimilar atoms, polarity will develop due to this difference in electronegativity value. Then the net dipole moment of the molecules. Dipole moment also very important factor for the formation of polarity in the molecules. Another thing is also, another factor also like this, difference in electronegativity. Difference of electronegativity value. If the electronegativity difference will be more, then polarity will be more. For example, HF, fluorine is very high electronegativity value compared to hydrogen. That's why HF is highly polar, because the fluorine is much more electronegativity than hydrogen. So difference of electronegative value is if more, then polarity will also more. Then dipole moment of the molecules. If dipole moment is net dipole moment also depends. What is the dipole moment, we will discuss later. Dipole moment and dissimilar atoms. If the molecule consists of different atoms, polarity may be developed. Then if the only similar atoms are available, then it is also non-polar. Let us discuss what is dipole moment. Dipole moment generally dipole moment is a vector. It is a vector quantity. It is a vector quantity. It is the dipole moment generally written as mu. Symbol is mu. Mu value is equal to, you can say, distance into charge. Product of distance between the two bonded atoms and how much charge is produced. It depends. As we know, when the electronegativity difference will be there automatically partial positive negative charge will develop. Then how much charge develop in between the atoms, or particular on the atoms, and how much distance they are placed during the formation of charge. So distance between the charge species, and how much charge is produced on the atom, that is called as dipole moment. So dipole moment is a vector quantity because it has magnitude and direction. It is the product of distance between the opposite charge ions and the charge on the particular atoms. So mu is equal to d into q, and it is expressed by dy. Generally the unity of dipole moment is dy, that 1 dy means d, 1d is equal to it is expressed as 10 to the power minus 30, approximately 10 to the power minus 30, that d into q, d means meter into q means coulomb. Q means coulomb, that is around 10 to the power minus 30 meter coulomb. That is 10 to the power 30 meter coulomb is equal to 1 dy. Approximate value is 10 to the minus 30, that how much? Meter and coulomb. This is the unit of 1 dy. Then this dy, if dy will be more, then dipole moment will be more. And this is expressed as mu. Mu is the symbol of dipole moment. But the dipole moment generally expressed by this symbol. This is the symbol of dipole moment. Dipole moment means a arrow sign having one vertical line. That indicates it is the formation of dipole moment, that is the polarity. So dipole moment, another factor is if mu value is 0, if net dipole moment of the molecule is 0, then it is non-polar. If mu will be 0, then it will be non-polar. Okay. Then another thing is very important. If mu value not equal to 0, may be positive or may be negative. Vector means either positive value or negative value. If mu less than 0 or greater than 0, if mu is not equal to 0, that is polar. Mu not equal to 0 means polar, and mu equal to 0 means non-polar. We have to see whether mu value is becoming 0 or mu value will be not equal to 0. We have to see in the molecule. For example, this dipole moment for suppose methane. This is a methane molecule. Methane molecule has 4 similar bonds. You come to this similar atoms point. You come to this point. As all hydrogen atoms are equal, only we have to see the bonded atoms mainly. As all hydrogen atoms are equal, all are equal. So if you see the dipole moment, as the carbon is more electronegative than hydrogen, already we have seen that for formation of partial positive negative charge, as carbon is more electronegative than hydrogen, the dipole moment of this bond will be towards carbon. Here the bond dipole moment will be carbon. This is because the symbol of dipole moment is like this, arrow sign and one vertical line. So here dipole moment towards carbon, here also towards carbon. So as all vector, this is a vector, you can say, this is a bond, you can say it is a vector. This vector, all are equal vectors, acting one point. We know that in law of physics that law of vectors, that equal vectors acting at the same point, resultant value will be net dipole moment will be 0. Here mu will be 0. Because all equal vectors, they will be cancelled, resultant vector will be 0. The resultant net dipole moment of methane molecule automatically will be 0. So it is non-polar. So bond may be polar. If you see CH bond is a polar bond, this CH bond is a polar bond, but the resultant dipole moment will be 0 because both are cancelling each other. For example, if you place one chlorine here and two hydrogen, if you see here 3 are equals but chlorine are not equal, so the dipole moment direction will be in this way, here towards in this way, here also chlorine, here also chlorine. If you see these 3 dipole moment and 1 will not be cancelled because chlorine dipole moment is not equal to which one? If you see all the dipole moment direction towards chlorine, because these 3 CH bond towards carbon and carbon towards chlorine. That means all are intercept towards in this direction. That means it is a mu will not be equal to 0. As mu is not equal to 0, they are not cancelling because all are in one direction. That's why mu not equal to means it is a polar molecule. So this is called chloroform, methyl chloride, CH3Cl. Sorry, this is a methyl chloride. Methyl chloride is a what? Polar molecule. But methane is a non-polar molecule. For example, carbon dioxide. Structure is very important. And the polarity factors affecting, you can add another point, that is structure also. So that is nature of bonded atoms, then that is whether similar or dissimilar atoms are attached, then dipole moment of the net dipole moment, that we are discussing whether mu is equal to 0 or mu not equal to 0. Okay, then another thing also shape. It depends upon mainly shape also. Another point you can write, that 4th point you can add in the 5th point, you can write that factors shape of the molecule. Shape of the molecule also gives rise the dipole moment value. For example, CO2, here shape is a linear structure. It is a linear shape. As a linear shape, CO bond dipole moment will be towards oxygen and the CO bond will be towards oxygen. Both are in opposite direction because the shape is linear shape. Linear shape means one will be right side, other will be left side. So this is a CO bond and CO bond, both equal bonds. Equal bonds and opposite direction. The resultant, like 2 equal vector in opposite direction, resultant mu value will be 0. Both will be cancelled. That's why, because in opposite direction, then one vector will be cancelled. If you add these 2 vectors, one is positive sign, other will be minus sign, because direction is just opposite. So resultant will be 0. You can understand this thing if you have knowledge regarding the law of vectors, parallelogram law of vectors, addition vector, subtraction vector. If you know this idea in physics, you can also understand this thing. So equal vector in opposite direction means the resultant dipole moment, resultant vector will be 0 because cancel each other. So carbon dioxide is a non-polar. You should have the knowledge regarding the shape of the molecule. That's why we have to read this VSEPR theory. Then another thing is, so for example, regarding SO2. SO2 shape is like this. SO2 molecule shape is like this. But if you see SO2, a sulfur has 6 electron outermost shell, 6, 2 oxygen means 4 share, then 1 lone pair remains. If you see this sulfur oxygen, your dipole moment in this direction, and sulfur oxygen dipole moment in this direction. If molecule has lone pair, the lone pair, the dipole moment always towards upward. Towards upward means if the that the lone pair availability. If you draw the lone pair towards up, then the dipole moment direction will be upward. If you place that lone pair down, then you have to write the dipole moment towards down. As it is placed above, so dipole moment will be this. So SO and SO2 bond, and here one lone pair is available, it cannot be 0. Mu value cannot be 0 because SO, this bond is not linearly placed. Because lone pair is available means due to repulsion between lone pair and bond will be just again coming closer. As it has no lone pair, bond is remaining straight linearly. As it has lone pair, already we have read in VSC pair theory that lone pair undergo repulsion with bond pair. Due to repulsion of lone pair and bond pair, the bond pair molecule again closer. That's why this bond will be, instead of 180 degree, it will be less than 180 degree because it will become closer. It was like this. When lone pair will be available, then bond will be closer. That's why resultant dipole moment will not be 0. Will not be cancelled because you have read in law that parallelogram law of vectors. When the two equal vectors having some angle that less than or greater than 180 degree, then automatically you have to a 180 degree, that is a highest, that is two vectors, 180 is a highest value. If it will be less than 180 degree, then it cannot be 0. That's why mu not equal to 0. This concept, if you have some knowledge regarding vector addition and subtraction of vectors, then you can understand this clearly. You know that in physics also you will read that two equal vectors having some angle, that is equal vectors, bond angle less than 180 degree, then the resultant dipole moment will not be 0. Resultant vector will not be 0. So mu will not be 0, so it is polar. You see, CO2 is non-polar, but SO2 is polar because having lone pair. So if it depends upon shape, because shape is your bent shape. This molecule has bent shape. This molecule is a linear shape. That's why we tell shape of the molecule also very important in the calculation of dipole moment. Okay? For example, here you see BF3 molecule. The shape is because BF3 has no lone pair, because boron has 5 electron, out of 5, 3 electron in outermost shell, 3 already share with 3 fluorine, lone pair available. Shape is a planar shape, triangular planar. Triangular planar shape means 120 degree. That is 120 degree. Both are in all are 120 degree. Here dipole moment in this direction. Here also one direction. Here also equal vector. All are equal, acting at the same point. So resultant mu will be 0. As mu 0, so non-polar. Although BF is polar bond, but one thing remember, bond may be polar, but the molecule may be non-polar because all bonds combined give rise to mu 0. If all bonds are equal bonds, having no lone pair, then BF3 is mu equal to 0. If you write NH3 having one lone pair, NH3 molecule having lone pair. Here dipole moment direction will be in this way. Dipole moment will be in this way. Here dipole moment will be in this way, and here also in this way. Dipole moment. And already I have told you, lone pair dipole moment will be in this way. For lone pair, if lone pair is available, it has also dipole moment. So result dipole moment, if you see, all are in same direction. So mu will not equal to 0. As mu not equal to 0, so it is a polar molecule. Polar molecule. Let us see another example taking NF3. NF3 has also similar type of structure like NH3, but you see dipole moment. NF3 N lone pair direction will be in upward, but fluorine will be downward because fluorine is more electronegative than nitrogen. It will be downward. It will be downward. You compare NH3 and NF3. NH3 all dipole moment in one direction. You see, just like same current, same direction. Okay, but here flowing in one direction. But here lone pair dipole moment upward, but NF bond downward because fluorine is highly electronegative. So if you see one is upward, other is downward, then mu value, although mu value not equal to 0, so it is also a polar. But if you compare with NH3, NF3, NH3 all dipole moment in one direction. So suppose it is mu1, suppose it is mu1, and NF3, suppose it is mu2. They both are not 0. So NH3 is a polar molecule, NF3 is a polar molecule. But which is more polar? We have to see the resultant dipole value. If here is all dipole moment in one direction, but here one upward, another downward. Two vector acting in opposite direction, always resultant value will be less. So here mu1 is greater than mu2. Here mu1 will be greater than mu2 because upward downward less value. That's why NH3 is more polar than NF3. NH3 more polar than NF3. NH3 is more polar than NF3. Okay, so as NH3 is more polar than NF3 because here all dipole moment in one directions, all are in one directions. Here one upward, other downward, so the value is less. That's why ammonia is more polar than NF3. So the polarity of covalent bond and the polar nature of covalent compound depends upon so many factors, whether the bonded atoms are similar or not. If dissimilar, then it depends upon the polarity, that is depends upon the electronegativity difference, and also depends upon the dipole moment, value of the dipole moment, net dipole moment, total dipole moment value of the molecule, taking all bonds, that dipole moment value, and also depends upon shape of the molecule. For example, CO2 having, that is Ab2 form, it is example of Ab2. Ab2 type, but linear shape. Here it is also Ab2 type. Ab2 type because A and B2, but its shape is bent. Here shape is linear. As linear shape, equal bonds. That's why the resultant dipole moment will be 0. Here same bond like your CO2, but it has bent shape. As bent shape, some angle produced between the bonded atoms. That's why the resultant dipole moment will not be 0. It has some net dipole moment as per the law of parallelogram of vectors. If equal vectors having arranged in some angles, not 180 degree, then the resultant dipole moment will be how much? Some value. It will give some net value. That's why it is a polar molecule. So it depends upon the shape of the molecule and availability of a lone pair, availability of bond pair, and the nature of bonds. Everything signify the polarity of covalent bonds and the resultant polarity of the compound. So the covalent compounds has a directional character. Conclusion we can draw that covalent compounds has covalent bonds has directional character like HF. The bonded shared pair of electron is shifted towards fluorine. So covalent bond has a directional character, but ionic bond has no directional character. So the directional character means formation of dipole moment in the molecule. When the bonded pair of electron is shifted towards one atom, then partially positive negative charge is produced. on the atoms. So these partial positive charge produce the resultant net partial positive negative charge in the molecule. If not equal to 0, then molecule will be polar. The molecule may have some polarity in the bonds, but the resultant dipole moment, if not equal to 0, then molecule will be polar. Okay, this is regarding the polarity of covalent bonds and the nature of covalent compounds. Okay, thank you.